Hello and welcome back. My name is Tarmo and I'm here to give you a tutorial today about correlation and regression. Right behind me here I've got some data that is obtained from the CIA World Factbook. It's available for free. Anybody can go and check out their site and see what you're interested in. What we have here is data for 202 different countries indicating the population, the number of internet users, which is also being presented as a proportion, and a GDP per capita value. And the question that we're asking is, what is the relationship between GDP per capita and internet users? So let's start. First of all, we're going to look at this table, and it looks like things in terms of columns aren't wide enough. So we're going to adjust those so that we can see what the data set looks like. We're going to highlight all of these columns that have our data. I'm going to put my mouse pointer between two of the columns so that the little icon changes, and I'm going to double click, and now all of the columns are wide enough to show all of the contents that they contain. Now notice that the country column is really wide because some countries have really long names. Some of them indicate sort of the former name that they had, but because we're not interested in the individual names of countries, we can take this column and just make it a little bit narrower so it's not taking up a lot of space on the screen, and we can keep the others as they are because those we're going to be coming back to and taking a look at. So now when I scroll to the top, we have nice clean data and it makes it relatively easy to work with. Notice that the proportion column is actually being calculated. We have here the ratio between the number of internet users over the population to give us a percentage, and that result is shown as a percentage so that the units work out really nicely on the screen and are easy to work with. We could scroll all the way down and see all of the countries all the way down to Zimbabwe here. But the question is there a relationship between GDP per capita and the proportion of individuals who are internet users in these countries? We're going to look at three different ways to do this. And I'm just going to turn myself off here for a second. You can see across the bottom that we have three different worksheets that we're going to work on. We're going to first do this graphically. We're going to create a scatter plot to show the relationship, and then we're going to add a trend line or a regression line, a line of best fit, to describe that relationship. Then we're going to figure out how we can do that and obtain the same information, but do that using built-in functions within Excel. And then we're going to do it using a table and sort of the long form method, because you may be asked to use one method or another, or given the option, you can choose which one you prefer. So I'm going to turn myself back on. There we go. And what I'm going to do is I'm going to first start by selecting these two columns of data, including their headers, down to the very last row. I'm going to head over to the insert ribbon, over to where it says charts. I'm going to hit that little down chevron and make sure that I choose scatter plot. Scatter plot is going to show up. I'm just going to move this thing back up towards the top of the page just so that it's where it's a little bit easier to take a look at. This is actually a little bit easier to do by cutting it and pasting it and moving it, but we only have a few lines to go, so let me just move it up to the top. Okay, so we have the graph up here at the top. I'm just going to drag the corner down. These white circles are called handles. If you grab them and you drag in any direction, you can resize your objects. It's something that we see with drawing objects, but also with mathematical objects and so on. The only thing here is that the axes are reversed of how I'd like to see them. Right now we have per capita along the y-axis and we have proportion along the other, but mentally it's a little bit easier to think about what is the per capita GDP and then read upwards in terms of what the percentage or proportion of internet users are. So I want to swap these axes. So I'm going to come in, I'm going to select the data. It brings the selection colors back up onto the screen. And what I'm simply going to do is I'm going to swap the blue one with the purple one. So I'm going to move the purple one back over and the blue one over here. And now we've got proportion along the y-axis, and we have GDP along the x-axis. Well, this is great, but it would be nice to have some information about what these axes are on the graph. So we can go over here to Add Chart Element. This is on the Chart Design ribbon. And we can go to Axes Titles, and we can add a primary horizontal axis. And we're going to do the same thing where we add a primary vertical axis. Notice that it says Axis Title, Axis Title. We can then go in here and we can edit this text to say GDP per capita, and we can put in the units so that it is nice and clear as to what this axis actually means. We can do the same here where we can select the title, and we can change this to proportion of internet users. Okay, that's great. The other thing that we might want to change here is the presentation of these values along the axis, because we're showing this to 2 decimal place precision, but they're all zeros, so it's just using up space on the screen. So we can modify these titles by formatting the axes and looking here in terms of how do we want to change the presentation of the values. So we're going to go down here to where it says number, and where it says decimal places, we're going to put in 0. This just makes it a little bit easier to look at. And then we can close this contextual menu with the little cross. So now we have a relationship where you can see that there's this increasing line where as we move to a higher GDP, we tend to have a higher proportion of internet users. So visually, we now have a scatter plot that helps us identify that there is likely a trend or a relationship between these two variables. What we want to do is add a trend line, a regression line, and get the equation of that line using tools on this graph. So we can right-click on the graph and head down here to where it says Add Trend Line. It's going to bring up this menu. We have different trend line options, but we're dealing with linear regression, so we want to add a linear relationship line or a linear trend line. And then we can scroll down to the bottom here, and we can check off these 2 boxes that say display the equation on the chart and display the R-squared value on the chart. Really great. We close this window, and now we notice that we have this important information on our screen. I'm just going to zoom in so that we can see it a little bit better, because it helps when things are a little bit bigger. So there we go. We see y equals, and then this value is given in scientific notation. We can right-click on here and format the trend line label, and we can choose how we want to format this information. So let's choose scientific, and we'll leave the rest as it is, but it now shows it to us with slightly more precision. We can actually change the number of decimal places on these values in that same menu, but we have relatively good idea of what these values now are. So if I scroll back to sort of a good level of zoom, we can see that we have the relationship, we have the regression line, and we have the regression equation, and we have our r-squared value on the screen. What we're going to do is work through this process in two other ways to show you different ways of getting this information, but the values that we get will be the same ones that we see on the screen right now. So I'm going to click on the second tab, which is to do this by functions that are built in. And I'm going to go over here. We already have the graph. It's here as a reminder as to what it looks like, but more importantly, the values are already on here so that we can ensure that we're getting the same values by doing this with the built-in functions. So the first thing that we're going to do is calculate the correlation coefficient, lowercase r. And the function in Excel is called correl. And what we need to do is specify our two arrays of data. So now without the headers, because we just want the numbers, the data, we're going to highlight all the way down here to the bottom of the first array. Then we're going to hit a comma because that's what it's expecting. And then we're going to select the second column of data, which is our proportion data. And we're going to close the bracket and hit enter, and we're going to end up with our correlation coefficient. The r-squared is simply the square of the correlation coefficient. So here we can put in equals, reference the correlation coefficient, the r, and then put in a square. So we put in the chevron and the 2, and we hit enter, and we get this value that is currently given to us in scientific notation, but we could go back and just change that to general, and we can reduce the number of decimal places, and we get 0.7240, which is the same value that we have on the graph. It's just on the graph, it's showing it to us in scientific notation. So it's a really quick way of getting the correlation coefficient. And now, if we want to find out what the equation is for a line of best fit, or a trend line, a linear trend line, a regression line, that is, we need this slope and this intercept value to build the same equation. So again, what we can go here, put in an equation. The function is called intercept, and notice that it wants to know the y's and then the x's. So we have to remember what is on the y-axis and what is on the x-axis. On the y-axis, we have the proportion of internet users. So let's highlight the data for y, comma, and we're going to highlight the values for x up to here. We're going to close the bracket, and we're going to hit enter, and we have here minus 3.12 times 10 to the power of negative 2, and that is exactly what we have up here. So again, maybe if I zoom in a little bit, we can see that a little bit better. We have here negative 3.12 times 10 to the negative 2. It's exactly the same value that we have here. And for slope, it's equals slope, and we're going to do the same thing where we have to put in our I need to zoom out a little bit, just otherwise it's going to get a little bit hard to see. Do that again, equals slope, open bracket. Again, it's the known y's and then the known x's. So these are our y's, the proportion. And it's really easy to forget and mix up your x and y. So it's really good to keep in mind what is on the x-axis and what is on the y-axis. We're going to highlight those, we're going to close the bracket to close the function, and we're going to hit enter, and we get here 1.58836 times 10 to the negative 5, which given the rounding here is exactly the same value. we could reduce the number of decimal places that we show here, and as you see, it is exactly the same. So we could then build the equation that says y is equal to this times x minus this. Y equals mx plus b, y equals the slope times the x value plus the intercept. And in this case, the intercept is negative, so it's minus the intercept, or plus the negative value of the intercept. Works out exactly the same thing. So a second way of getting at that relationship information. Now we're going to look at the third case, which is working this out in long form in tabular form. And it's looks a little bit messy, and there's a lot happening here on the screen, but let me simplify the idea for you. Notice first of all that this table looks like it's shrunk considerably from top to bottom in terms of the number of rows. All of the data is there, but notice that the rows are numbered 1, 2, 3, 4, 5, 6, and it jumps to 204, 205, 206. All I've done is I've selected those intermediate rows, and I've right-clicked on them, and I've selected to hide them. And what it does is just simply removes them from the view so that I don't have to keep scrolling to the bottom every time, so that we can see the bottom of the table and the top of the table at the same time. All of the countries, all of the data, all of the proportions, all of the GDP data are still there. It's just that it's like we folded the page so we can't see all of them at the same time, just to make things less cluttered while we're moving around on the page. So what we have here, I've added y and x to remind us of which is the x variable, which is the y variable. And then I have added these three additional columns, xy, x squared, and y squared. This is relatively simple. All we're doing here is we're multiplying the x data with the y data. And we do that for each country moving down. Here we're taking the x values and we're squaring them. So we're taking all of these values and simply squaring them. And here we're taking the y values and we're squaring them. So relatively straightforward. Then when we get down to the bottom here, we're taking the sum of all of the values within that column. So if I look at this one, it's the sum of E4 through E205. So it's going all the way down through the table and calculating the sum of those. And we do that for each of these columns. So that's great because these sums equate exactly with the requirements that we have in the equation for calculating the correlation coefficient. So the equation for the correlation coefficient, I've put it in here in the format that's by the equation editor, and it shows us that we need information about n, the number of observations, or the number of countries. We have the sum of x times y's. We know that the sum of x times y's is given to us right here. We know that we need the sum of x's and the sum of y's. We have the sum of x's and the sum of y's. And then we have the sum of x squareds. So the sum of x squareds here. We have the sum of x, which is this, squared. And then we have n again, which we already know. And we have the sum of y squareds. And then we have the sum of y's squared. So what we're trying to do now is find the proper values in our table that we just calculated and plug them into the proper locations within this calculation. N, all I did was I did a count of all of the values in this column so that we know that there are 202 countries. We have our n value. We have these values from before, r and r squared, just as a reminder as to what they are. And then I'm going to scroll a little bit to the right so we have it all in here. All I have done is I have taken the same equation that I had up above, I copied it down below, but then I replaced all of the n's with 202. I replaced all of these terms with the corresponding values from the table. And you can take a look at them here. I've described them in the lecture, and you can see where they're coming from so that you can get familiar with how these values are actually computed. We could then type this into a calculator and solve for R. We could do this in Excel, but sometimes building these calculations or these formulas gets to be a little bit hair-raising because we've got all kinds of brackets and divisions and it gets a little bit nutty. So what I often do is I break it down into smaller pieces. So here I have the numerator, that's the top of this fraction, and the denominator, the bottom of the fraction. I solve the top and I solve the bottom, and then here I actually do the division of the numerator and denominator. It's a little bit easier to keep track of where all your brackets are going. I'm going to show you, if we double click on here, the formulation simply points to the values in the table as necessary to solve the top of this calculation. So we have here F209, that's our 202 value showing up here. G206 is taking this value from here, minus F206, which is this value right here, and we multiply it by E206, which is this value right here. So n times the sum of x times y minus the sum of x's times the sum of y's. And when it solves it, we get this big value, which is only an intermediate step, but we do the same thing on the bottom where we can work again inwards and then outwards through all of these brackets to see where the values are coming from. And it's nice that they're color coded. It reminds us of where they're coming from. So F209 is our n value. H206 is this value here, the sum of x squareds, and so on throughout this calculation. And then all of that is sent to the square root, which encompasses the entire denominator. So when we run that out, we have these two values, and then all we're doing is making a division between these two, and we end up with our R value, our correlation coefficient, which is 0.85, which is exactly what we had before. And if we were to then square this, we would have our R squared value. And then the similar kind of process for calculating the slope and the intercept, the equations also draw on these same kinds of data, are relatively easy to implement. So I leave this to you to try to insert the equations into your workbook and practice and test that they work. It's going to make your life doing regression and correlation much easier when you have a table and these referencing systems already built in to form your calculations.